Today, I'll show you how to visualize any color correction tool in Blender as a curve. We'll build a small setup that I call Curve Analyzer. The idea for this tool comes from Edmond Amir again, who created a similar project for Photoshop called Live Curves. Here we'll adapt this idea for Blender and see how Curve Analyzer can help us under behavior of different color correction nodes. You can build a similar setup in almost any image editor and get a better feel for how its tools actually work. We'll also talk about the new Closure tool. I'll share how I understand it and explain how, in my opinion, it differs from regular node groups. Let's jump into Blender and build Curve Analyzer step by step. First, delete the default cube, add a plane, and assign a new material to it. Add a texture coordinate node and use the UV output. UV gives us two linear gradients, one along X and one along Y. We split UV using separate XYZ, and then, with combined RGB, we assemble two separate black and white gradients, one along X and one along Y. Next, we take these two gradients and plug them into a mix node set to difference. Where the values are the same, the difference is 0, that gives us a diagonal line. This is our default diagonal. The idea is simple. As long as both gradients are linear, their match lies exactly along this diagonal. As soon as we distort the X gradient with color correction, the diagonal bends. And from this bend, we can read the curve of the tool. Right now, difference gives us a soft gradient around the diagonal. We want a thin stripe near 0, so the line is crisp and easy to read. Add an RGB curves node and plug the difference result into it. Then invert the curve, add an extra point in the middle and pull it down, and set this point to auto-clamped and move it a bit to about 4 thousandths along the x-axis, so that almost the entire range becomes dark. In other words, we're reapplying a strong clamp around 0. Where difference equals 0, we get a bright line. Everything further away from 0 is pushed to black. Instead of a soft transition, we now have a thin, bright line. This will be our graph. When we run the X gradient through a color correction node, this line bends, and its shape shows us how the tool behaves. Now we'd like to add a scale control, so we can see the graph outside the 0 to 1 range as well. Add a scale node and multiply UV by some value. You'll immediately see that scaling happens from 0. Everything shrinks or grows from the corner, not from the center. That's not very convenient, so let's switch to object coordinates instead. By default, our plane is 2 by 2 units, and object coordinates go from -1 to 1 along both axes. That means scaling will happen from the center of the plane. Next, add a math node in divide mode. Keep 0.5 on top, 1 on the bottom, and feed its output into scale. Then add 0.5 to X and Y, so we bring the range back into 0 to 1. This gives us a handy scale slider. For example, set it to 0.9. Now we can comfortably zoom in on the details around 0 and in the neighborhood of the diagonal. When we change the scale, it's very helpful to always see where the true 0 to 1 range is. Let's build a frame. Take the X gradient, use a compare node. With default settings, it outputs 1 inside the 0 to 1 range of our gradient and 0 outside. Do the same with the Y gradient. Then multiply the results, so that only a frame around the 0 to 1 square remains. Add this frame on top of our graph using a mix node in Add mode. Set the vector slightly above 0, so the frame gently highlights the area we care about without overpowering the lines. Now, no matter how we change the scale, we can clearly see where 0 and 1 are on both axes. From this node tree, it's natural to want a single node group that you can add to your asset browser. But there's a catch. We want to be able to plug any color correction tool inside it. And that's exactly where the Closure tool becomes useful. We add a Closure node and plug our curve into it. Then we create an Evaluate Closure node and connect it at the point in the tree where the curve used to be. Now we can turn the whole tree into a node group, and thanks to closure, we can plug any color correction node inside that group. If we add another evaluate closure, we can, for example, place it inside the shader. This way, we can use our color correction directly in the shader, and at the same time see how this entire correction chain behaves as a curve. This is the main strength of closure. As your node trees grow, it becomes very convenient to reuse the same node setup in different parts of the tree, feeding different inputs into it and getting different results, while keeping exactly the same logic inside. Of course, we already have regular node groups, and in many cases they're enough. But with the closure tool we get more flexibility. Now a node group can act as a wrapper around another node group, or around any other node block we want to drop inside. Let's add a mix node and set it to soft light. For the second input, set the color channels to 1 for red, 0.5 for green, and 0 for blue. The graph turns into a characteristic set of curves, and we can see what soft light does over the 0 to 1 range. Now I suggest you try this yourself. Run brightness, contrast, gamma, and all the blend modes through this analyzer. This will help you understand when each blend mode and color correction tools in general might be useful in your own work. Keep in mind that if you want to inspect hue saturation value node, you first need to separate the curves for different colors. The soft light setup we just built works well as a base for that. Now let's move this setup into the Compositor. There are more color correction nodes there, and it's interesting to look at them with the same approach. Create a new compositing node tree. Copy our node graph over. Some nodes won't make it across when you paste. For convenience, we'll make the project resolution 1024 by 1024. To get a gradient, similar to the one we had in the shader editor, use a gradient texture node and plug an image coordinate node into it. We'll need the uniform output. Feed that into the same place where we previously used texture coordinate object, so we can rebuild the same XY gradients, difference, line and frame. The combine color node in the Compositor has an alpha channel, and that's why it doesn't transfer directly from the shader editor. Just add it manually and reconnect it the same way. From here, the logic is exactly the same. We feed different compositing color correction nodes into our analyzer and see what curves they produce. There's no closure tool in the Compositor yet, so if you want to build a node group there, you'll either have to split it into two groups or just work directly inside the node tree without closure. So that's our curve analyzer, and a quick look at how the same idea works in the Compositor, plus a small taste of what the new closure tool can do for more flexible setups. If this setup helps you solve a real production task or understand a tricky node, I'd be happy to hear about it in the comments. And if you found this video useful, please like, subscribe, and leave a comment. It really motivates me to make more interesting videos.